Good day, viewers. Today, I'm going to show us a method called Chios condensation method that we can use in reduction of matrix. So this method is called Chios condensation method. What do we mean by Chios condensation method? Chios condensation method is a recursive algorithm used to reduce n by n or a by a matrix to a 2 by 2 matrix. That is, when you are given a higher order matrix, like matrix of order 5 by 5, I'm talking of square matrix. When you have matrix of order 5 by 5, a matrix of order 6 by 6, and you are asked to get the determinant, you will see that it's kind of confusing to use the normal method, and that's why we have this Chios condensation method, which we can use to reduce the matrix, be it from 5 by 5 to 4 by 4 and subsequently to 3 by 3, and from 3 by 3 we can use our normal method and get the solution of the determinant of the matrix. So I would like to write the definition on the board. Chios condensation method is a recursive algorithm method used to reduce n by n matrix to a 2 by 2 matrix. So this is the definition to this. I've explained what it means earlier. So now, to get better understanding about this topic, we can take example. So we are going to find a determinant of a 5 by 5 matrix. Given example 1, I'm going to take just one example. Given A equals, A is the matrix. So we have a matrix 5 by 5. And your first row, you have 4, 3, 2, 6, 1. You have 2, 1, 3, 4, 0. Then you have 2, 3, 5, 2, 1. You have 4, 2, 2, 1, 1. Then lastly, on the fifth row, you have 0, 1, 0, 2, 3. So this is the matrix. Now to find the determinant of A. Find the determinant of A. Solution. So to get the determinant of this now, we can apply this Chios method. The rule says that you look at your pivots. Ensure that your pivot is not 0. Your pivot is the first element on this first entry here. So when you look at the example I gave here, our pivot is not 0, which means that we can proceed to the next step. Assuming our pivot is 0, we can do the interchanging of row or column. So when we perform that, then we can now pick our pivot. But here, luckily for us, this pivot is not a 0, it's greater than 0. So let's proceed. Now we are going to apply the formula that the determinant of A will be equal 1 over, what is our pivot? Our pivot here is 4. So we have 4, all raised to power. How many rows do you have? We have 5 minus 2. The minus 2 is always a constant. So we are going to reduce this. What we are trying to do now is to reduce this matrix into a 4 by 4 matrix. So to do that, let's be picking it 2, 2. We have this 4 and 2. Then we will pick on the second column as well. We'll pick 3 and 1. So to form a 2 by 2 matrix, we have 4, 2, 3, 1. That's 1. Then we have another one, 4, 2, and then on the third column we have 2, 3. 2, 3. Now we have next one, 4, 2. On the fourth column we have 6, 4. And finally we have 4, 2, and then 1, 0. So we continue. Now we are using the pivot and then this third row. Now we have 4, 2 again. 4, 2, because we are going to reduce this matrix to a 4 by 4 matrix. 4, 2. Then we have 3, 3. 3, 3. We are still using that 4, 2. Then on the third column, we have 2, 5. 2, 5. We still have that 4, 2. And on the fourth column, we have 6, 2. 6, 2. We have 4, 2. And then the last column here, we have 1, 1. 1, 1. All right. We still have the first row and then the fourth row. So we have something like 4, 4. 4, 4. And then 3, 2. 3, 2. You have 4, 4. And then on this third row, we have 2, 2. 2, 2. We have 4, 4. And then here we have 6, 1. 6, 1. And then we have 4, 4. And then what? Then 1, 1. 1, 1. Now, for this matrix to become a 4 by 4 matrix, we still need another 2 by 2 matrix on this last part. So we have 4 and then 0. 4, 0, 3, 1. Then we have 4, 0, 4, 0, 2, 0. 2, 0. Then we have 4, 0, 6, what? 6, 2. 4, 0, 6, 2. 4, 0, 6, 2. We still have our 4, 0. And then 4, 0, 1, 3. 1, 3. All right. Let's do the 2 by 2 determinant for each and every 2 by 2 matrix we have here. So we can say that determinant of A will be the same thing as 1 over 4 raised to power 3 into what we have here. 4 times 1 is going to give us 1 minus 3 times 2. That's 4 minus 6. And that's going to give us minus 2. The next one, we have 4 times 3. That's 12 minus 2 times 2. That's 12 minus 4. You have 8. Next one, we have 4 times 4, which is 16 minus 6 times 2. That's 4. That's 16 minus 12. And that's going to give us 4. And then we have 4 times 0. That's 0 minus 2. That's going to give us minus 2. All right. The next one, we have 4 times 3. That's 12 minus 3 times 2. That's 12 minus 6. So we have 6. The next one, we have 4 times 5, which is 20, minus 2 times 2, which is 4. So we have 20 minus 4, we have 16. And the next one, we have 4 times 2, which is 8, minus 6 times 2, which is 12. We have 8 minus 12. That's minus 4. And then we have 4 times 1, which is 4, minus 1 times 2. That's going to give us 4 minus 2. And that's going to give us 2. Then we have 4 times 2. That's going to give us 8 minus 3 times 4. We have what? We have 8 minus 12, and that's minus 4. We have 4 times 2, which is 8, minus 8 is 0. And we have 4 times 1, which is 4, minus 6 times 4, which is 24. We have 4 minus 24. We have minus 20. And then we have 4 times 1 minus 1 times 4. That's going to give us 4 minus 4. And we have 0. And lastly, here we have 4 times 1 minus 3 times 0. It's going to give us 4 minus 0. And that's going to be 4. Here we have 4 times 0, 0, minus 2 times 0. That's going to give us 0 minus 0. And that's going to be 0. Then we have 4 times 2 is 8, minus 6 times 0. That will give us 8 minus 0. That will be 8. And then we have 4 times 3 minus 0 times 1. That's going to give us 12 minus 0. Here we have 12. So we've been able to reduce this 5 by 5 matrix to a 4 by 4 matrix. Then now, let's use the same process and reduce this 4 by 4 matrix to a 3 by 3 matrix. So we can say that the determinant of A will be the same thing as 1 over 64 times, now our pivot here is what? Is minus 2. So we have times 1 over bracket minus 2 all raised by how many rows? Number of rows is 4. 4 minus 2. Now, let's use the same process. So we have to break them into 2 by 2 matrices. So we have minus 2, 6, minus 2, 6, and then what? 8 and then 16. 8, 16. Then we have minus 2, 6, and then when you look at it, we have 4 minus 4. And lastly, we have minus 2, 6, and then minus 2, 2. minus 2, 2. Next one, we are going to use the pivot and this third row. So we have minus 2, minus 4, minus 2, minus 4, and at what? 8 and 0. Then minus 2, minus 4. Then we have 4 and minus 20. Then we have minus 2, minus 4. And then lastly, we have minus 2 and 0. Minus 2, 0. Now let's do the last part. We have minus 2 and 4 now. Minus 2 and 4. And then this will give us, now the next one is what? 8 and then 0. 8, 0. We have 8, 0. Minus 2, 4. And then 4 and then 8. 4, 8. And lastly, minus 2, 4. Then we have what? Minus 2, 12. Minus 2, 12. Minus 2, 12. Minus 2, 12. All right. Let's reduce this now. You can just multiply everything you have there. So here we are going to have the determinant of A to be 1 over 64 times 1 over 2 raised power 2 minus 2 raised power 2 is going to give us what? 4. So we have times 4 into, now let's multiply each and every term we have here. We are going to have, let me take calculator, apply some things. So we are going to have minus 2 times 16, that's minus 32, then minus 48. You have minus 80, minus 80. Then next one, we have minus 2 times minus 4 is going to give us 8. 8 minus 24. And that's going to be minus 16. Minus 16. The next one, we have minus 2 times 2. That's going to give us minus 4. Minus 4. Then minus times minus is going to give us plus. So we have minus 4 plus 12. That's going to give us 8. We have 8. Okay. And then for this one, we have minus 2 times 0. It's going to give us 0. Then we have 4 times 8. That's going to give us 32. The next one, we have minus 2 times minus 20 as what? As plus 40. Then plus 16 is going to give us 56. 56. And then here, minus 2 times 0 is going to be 0. Then we have 2 minus 2 times 4. Because this minus 4 times minus is going to give us 8. Then remember there's going to be minus there because it is AD minus BC. So it's going to be what? Minus 8. Minus 8. And then here we have minus 2 times 0. We have 0 minus 4 times 8, which is minus 32. So here we have minus 2 times 8. We have minus 16. Minus 16. Then minus 16 again. That's minus 32. We have minus 32 again. And here we have minus 24. Minus 24 plus 8. we have minus 16. That's 24 plus 8 is going to give us minus 16. Now we can use our normal method of finding determinant to get this. So to use that, I'll quickly rub this. So determinant of A, the determinant of A is going to be 1 over 64 times 4 is going to give us 256. 256. Now, let's use the normal method. You have this as plus, minus, plus. So, plus times minus is going to give us minus. We have minus 80 into, now you clear this row, you clear this column and you clear the row. What do you have left? You have a 2 by 2 matrix of what? 56 minus 8 minus 32 minus 16. So this is going to be 56 into minus 16 minus 56 into minus 16 minus, so minus times minus has become plus. So you have 32 into 8. Because when you have minus times minus, it will still give you plus. So there's no need of putting minus 32 into minus 8. You can just simply write 32 into 8. Alright, so we're done with that. The next one, this is carrying minus. So you have minus times minus 16 is going to give us plus 16. So you have plus 16 into plus 16 into, now you cover the column and you cover the row. So covering that, we have this, and this. Such that we can say that we have 32 into minus 16, 32 into minus 16, minus, you cover it, you have 32 into minus 16, and then what? Minus 8 times minus 32 is still going to give us what? 32 times 8. So we have 32 into 8. Okay. Cover it up. Then we have plus 8. Plus 8 into, now when you cover this, you have 32 times minus 32 into minus 32. 32 into minus 32. Then plus, it's going to be plus because there is minus here, and then you have minus, you are going to have a negative value. So minus times minus will give you plus. So into 56 times 32. Okay. Now let's simplify this one by one. We can say that the determinant of A is equals 1 over 256 into minus 80 into 56 times minus 16 is going to give us minus 896. Okay, minus 32 times 8 is going to give us 256. Minus 256 plus 16 into 32 times 16 into minus 512 minus 512 minus 256 minus 256 plus 8 into 32 square. That's 32 times 32, which is 1024. Sorry, it's minus. You have minus 1024 plus 56 times 32. You have 1792. Alright, we are getting there. The determinant is 1 over 256 into, you have minus 80 into minus 896 plus 256. That's going to give us minus 1152 plus 16 into, when you subtract 512 plus 256, you have 768 into 768, and then finally plus 8 into, when you subtract 1792 minus 1024, you have 798 as well. 768 as well. 768. So we can open this. Let's just simplify that and we'll get our answer. We have the determinant of A, so be the same thing as 1 over 256 into, minus times minus is plus, then 80 times 1152 is 92160. 92160, that is 92,160 plus 16 times 768, you have 12,288 plus 8 times 768, that's 6144. So on adding everything together, I say that our determinant is 1 over 256 into, let's add everything all together. We have 92,160 plus, coming, okay, sorry, there's minus here, there's minus there, so this is going to be minus 12,288, and this one is surely plus. So I think that's the only error we have there. 92160 minus 12,288 plus 6144. We have 86016, that is 86,016. So finally, our determinant can be the same thing as 86,016 over 256. So the determinant of this matrix A is equals, let's divide. So on dividing, we divide by 256. We have 336. 336. And that's the answer to this question. That's the answer to this question. So this is a very simple question. So I'm going to give you an assignment and you drop your answer in the comment section. So it's very simple. Just follow the normal procedure. You get the answer to the question. So I'm going to give just one question as an assignment. You can drop your solution in the comment section. So assignment. Given B equals this matrix. Given B is this matrix, and find the determinant of B. Thank you, viewers.